This is an isosurface visualization of air pressure inside a rolling tire, built with the afterburner engine using a custom GLSL fragment shader. The tire is modeled as a torus, a donut shape. The large radius represents the wheel, and the tube radius represents the tire's cross-section where the air sits. The scalar field here is air pressure in PSI, computed at every point in 3D space inside the tire cavity. It's based on real physics. There's a uniform base inflation pressure, typically around 35 psi. On top of that, three effects modify the pressure distribution. Where the tire meets the road at the bottom, the rubber deforms and compresses the air, increasing local pressure. This is from the ideal gas law, PV equals nRT. Less volume means more pressure. The tread rubbing against the road generates heat that conducts through the tire wall into the air. Hotter air means higher pressure, and this effect is strongest near the contact patch and near the tire wall. As the tire spins, the air is pushed outward toward the tread, slightly increasing pressure at the outer wall. The isosurface shows the boundary where pressure equals a chosen PSI threshold. When I lower the threshold, the surface expands because more of the air cavity is above that pressure. When I raise it, the surface shrinks down to only the highest pressure region near the contact patch. Notice the colors don't change. They represent the actual pressure at each location, independent of the threshold. The color mapping goes from blue for low pressure through green for normal, yellow for elevated, and red for high pressure. You can see the bottom of the tire near the contact patch is yellow and red, while the top is blue-green. That's the pressure gradient from the road contact. The cross-section mode cuts the tire open so you can see inside the pressure distribution, useful for understanding how pressure varies through the interior. Increasing the rotation speed increases the centrifugal effect and friction heating, which you can see raising the overall pressure and shifting colors. There's also a volumetric rendering mode that shows the pressure as a translucent cloud instead of a hard surface, giving a different perspective on the distribution. This kind of visualization is used in tire engineering. Companies like Michelin and Goodyear use finite element analysis with similar pressure and stress fields to design tires for performance, safety, and efficiency. The isosurface lets an engineer quickly identify which regions exceed a pressure limit, while the color mapping shows the full distribution at a glance. Thank you for watching.